The derivative of cosine is negative sine of x. So doing my u substitution, this becomes the integral. We have the sine of x over the square root of 5 minus u squared du over u prime. And then as expected, the signs are canceling out, and we can go ahead and find the antiderivative. There is a square root sign, and you're subtracting the variable, so we know it has to be arc sine. This is from our a value. Well, what squared is going to give you 5? The square root of 5 is going to give you 5. Remember, for arc sine, there is no 1 over a in front, but we do have a negative to deal with. So we will have the negative of the arc sine of u, which was cosine, over a plus c. And that's how I would expect you to kind of answer that question. I will say mathematically and technically, the integral of something that's negative arc sine is mathematically the same as saying arc cosine. So technically, this is the same answer. I'm going to prefer that you do it this way because the AP exam is only going to use arc sine as an integral answer and not arc cosine. And also, to be honest, I usually know people are using like an app or a web page just to do integrals if they give the answer of arc cosine. That's what the computer will give, but a human's going to evaluate it as negative arc sine. So there's that first one. The middle one, let's talk about this one. I know this would have to be inverse trig because the degree of the denominator is 4. The degree of the numerator is just 1. 4 is more than 1, bigger than 1, so we know it has to be inverse trig. There's no square root sign, and I see the two things are added, so I know it has to be an arctangent rule. If it's an arctangent rule, I want to think of the variable part as something squared. Well, what squared is going to give you x to the 4th? Of course, x squared is going to give you x to the 4th. So our u is going to be x squared. What will be our u prime? 2x. Thinking of how that will cancel, the x's will cancel out, but we would have 1 over 2 left over from the u sub. And then we can go ahead and do the arctangent rule. If we see a 16 here, we know that a value is 4. Arctangent does have 1 over a in front, and so I have the arctangent of u over a plus c. So again, that one's pretty straightforward. Some people mess up with the coefficients. Again, arctangent does have 1 over a, and then we also have the 1/2 from the u substitution. And then the last one I want to do, I think this one is the trickiest one, just because that arcsecant rule in itself is kind of weird. I wrote the rule, it's kind of small, but up at the top of the page, I'm going to zoom real big to look at it. And the arcsecant rule, what makes it weird is when you integrate, you have like 2 u's in the problem. And like both of those u's need to show up in the problem if you are doing the arcsecant rule. So if I'm looking at this problem, I know it's arcsecant. We have a square root sign, but the variable is coming before the subtraction sign, and we have something outside that square root sign. So I first think of how can I write 9x squared as something squared? Well, 9x squared can be written as 3x squared. And so 3x is going to be our u, but what we have to be careful with is in order to do the arcsecant rule correctly, that u has to also show up outside that radical sign. There's different ways to kind of make that happen. To me, the easiest way is like, well, I'll just put a 3 there. Why not? Like I want that to be a 3x so those two match, but I can't change the problem. So if I put a 3x in the denominator, I just also want to stick a 3x in the numerator. Then I'm really just multiplying by 1, and I'm not changing the problem. So then kind of finishing out, probably should have also given me more space, but u prime would be 3. So rewriting this, I have 12 up top. 3x is u on the square root of u squared minus 25. Dx is du over u prime. So that 3 we multiply by does end up going away, but again, we kind of needed it there to turn that first thing outside the radical into a u. So then now doing the arcsecant rule, we have a 4 that's a coefficient times 1 over a. And then we have the arcsecant absolute value of u over a plus c. And you can leave your answer like that. Remember, for arcsecant, it does have to have absolute value signs instead of parentheses. Marcus.
So if you're doing substitution, you just substitute that x to 1/3 u and.
Yeah, so like another way to do it is, and for those of you at home who couldn't hear, like that x, you can kind of do some things like if you're using this u equation, you can turn it into, I need more space, but x is equal to like u over 3. And you would end up with the exact same answer. There's other ways to do it too, like if you actually look at how I typed it in on the next slide. Not always my favorite way to do it, but you can just factor out the 9 and then just avoid doing u sub completely. So there's another way you can do it as well. So there's kind of like 3 ways to approach it. But again, that's kind of why arcsecant's weird, because kind of like the 2 spots where the variable shows up. Any other questions on those 3? Yes.
So do we have to like multiply the 4 and then 1/5?
You can leave it like that.
Okay.
Fine by me. Any other questions? All right, so I just want to kind of go over this week again, and then I'll kind of open up for homework questions if there are any. So again, I showed you this yesterday, but this is kind of like what the next 2 weeks honestly looks like. So again, the first thing you want to do is making sure you can kind of complete homework 3. Like if you're one to like make a to-do list, that's what I kind of want on the top of your to-do list. Finish homework 3 first. And then when you finish homework 3, you can then ease into and continue working on homework 0. Homework 0 again was like the AP questions that we're reviewing. And then homework 4 is like that last homework I'm assigning this unit that just has a whole bunch of integrals mixed together. Do read the instructions on homework number 4. I don't make you do all the questions. It says to choose like 2 questions per row. So like when you pull it up, it's just going to look like a table, just like a ton of problems. Just choose a minimum of 2 questions per row. So again, if you're prioritizing, I would work on homework 3 first and then move into the other homeworks. Honestly, all this week you're just practicing. I want you to feel confident finding integrals. I need you to be able to find them pretty quickly and correctly, of course. Wednesday is going to be a work day. Thursday is a work day. Next Tuesday is also work day. And I'll kind of open up each class with like answering questions, and then kind of you have the rest of the time to do what you need to do. So like once you finish the homework, I would then kind of transition to working on like the briefcase binder stuff. And then if you finish the briefcase binder stuff, I'll talk about it later, but I do have some extra optional, not required practice that you can do as well. But right now, there are some questions on homework 3 that I assigned on purpose, like there are some tricky ones. So I'll start with people at home first to take questions. And again, if you just want to like halfway listen because you don't have questions, that's also fine as well. I would not be offended. But anyone at home have questions from homework number 3 you would like to see worked out or at least started? All right, then. Anyone at home have a, yes, Taylor?
Number 28.
28. I think I've done this one every period, which makes sense. Was your question with the evaluating or finding the antiderivative?
All of it.
All of it, cool. So looking at 28, and again, feel free to follow along. This is one of the definite integral ones. Make that a little bit bigger so we can see it. I'm going to treat this kind of like an indefinite integral one at first and kind of ignore what we're looking at. And when I look at this one looks like it could be one that I do with like rewriting with the -1/2 exponent, bringing that square root, add the denominator. But I quickly noticed that the exponents of the e doesn't really match up. So this is kind of one of the weird ones that is an inverse trig problem in disguise. How is it an inverse trig problem? Is I can think of that second part as something squared is giving you e to the -2x. Well, e to the -x squared is going to give you e to the -2x. We know that when we have a power raised to a power, we multiply. So doing our u substitution, our u is going to be e to the -x, u prime, don't forget the chain rule. The derivative of e to anything is just e to anything, but then the chain rule is going to give us a -1 there. So doing my u substitution, like we can see that e to the -x's are going to cancel out. Du over u prime, don't forget that -1, and then evaluate. So these cancel out. Don't forget about the -1. And then this is the arcsecant rule, the arcsine rule. So I have the arcsine, a value is 1, so then I just have u, and u is that. So that's the antiderivative of it. But this is a definite integral, so we still want to evaluate this from the natural log of 2 to the natural log of 4. Questions from really anyone up until that step? All right, and then evaluating it, so I have the negative arcsine of e to the negative natural log of 4 minus a negative arcsine, so it's going to become a plus sign, of e to the negative natural log of 2. And that's probably as far as many of you do it, like if you just had to plug in the top minus the bottom, like if this was honestly my test for the quiz, you could leave your answer like this. Would this be a question, multiple choice option on the AP exam? No. How do I know I can simplify this? I know that when e and a natural log are touching, then they cancel each other out. So you basically use some properties of logs with like coefficients to simplify this. And the property you're using, if you remember, if you have a coefficient in front of a logarithm, you can move that coefficient up as an exponent. So when I say the negative natural log of 4, that's like -1 times the natural log of 4. That's the same thing as saying the natural log of 4 to the -1st power. Well, if I have 4 to the -1st power, that's the same thing as saying 1/4. You're like sending that 4 back into the denominator. So I can rewrite this problem with some fractions. So that one becomes the natural log of 1/4 in the exponent. And the second one becomes the natural log of 1/2. Once the e and the natural logs are touching, since they are inverses, they cancel each other out. So I have the negative arcsine of 1/4, which is not on the unit circle, can't do anything with that. The second one is the arcsine of 1/2, that is on the unit circle, so you can evaluate it. That means when it's sine equal to 1/2, sine is equal to 1/2 at pi over 6. And I believe that's how the answer was left, like pi over 6 minus the arcsine of 1/4. Yes,
So just to be clear, you're totally fine with us leaving the answer?
yes, if this was my quiz, like you could leave it like this. But on the AP exam, it definitely would have gone down that last line.
Okay.
Any other questions from homework 3 you want me to work out?
Can you do number 32?
32? This is also a good one. And this one is definitely one, especially if you didn't have me last year, you wanted to see, because it does actually involve taking the derivative of inverse trig. So this is 32. This one is kind of like a regular U-sub problem in disguise. So it looks like you should be integrating with arcsine just when you're looking at that denominator. But this was an arcsine problem, like that numerator should just be like a 1 or a 4, like just some number without a variable in it. So that arc cosine is kind of messing things up. So how you actually approach this one, I'm going to borrow those letters. You're going to let your u be equal to the arc cosine of x. And again, if you had me last semester, you should know this. If you didn't, I'm telling you now. The derivative of arc cosine looks the same as that integral we use for arcsine. It's just the negative version of it. So then when you go back and do your u substitution, again, I'm going to ignore the definite integral part right now. Arc cosine becomes your u, and it's all over 1 minus x squared. Dx is du over u prime, and u prime is this fraction kind of within itself. What cancels? That denominator cancels, and you're really just integrating the negative of u. So it's kind of like, it looks like it should be tricky, but once you do u sub, it becomes a pretty basic integral to solve. And of course, plugging the u back in. If you want another one like that, I don't know the number, but in homework 4, it's on the second or third page. I know the problem's in the very bottom right-hand corner. I don't know why I remember that, but there is one very similar to that in homework 4 on like a bottom right-hand corner of the page, if that makes any sense at all.
Yes, page 3.
Page 3, thanks. I think it's an arc sine and the arc cosine one.
Yes.
Yes, Taylor?
Why do you have to raise the exponent on U? Because you're just.
Well, you still have to integrate it, right? So you're
Yeah.
still integrating u, so you still have to kind of go through the antiderivative process. Yes, Mitch?
Where did that 1/2 come from?
That's the antiderivative of, like, right, like if I just went back, let's not confuse ourselves, like if I'm integrating just x, that becomes 1/2 of x squared, right? Well, I'm
Oh,
integrating
okay.
u, so that's what I'm doing instead.
Okay.
Any other questions from homework 3?
Can you do question 40?
40, yeah. 40, I will get you started, because this is kind of a longer one. 40, kind of comparing those, definitely inverse trig, but right now, what's inside the radical sign doesn't really work. To get you started, this is actually going to be one you have to complete the square on. So remember, you have the x squared minus 2x, leave a gap, and there's really nothing else after that. Didn't really need to worry about factoring out anything. Add the b over 2 squared, balance it, subtracting the b over 2 squared. First 3 terms will give you your binomial. So we have x minus 1 squared minus 1. And then it's actually going to be an arc secant rule. And you can kind of see how that works out because what's being squared on the inside exactly matches what's on the outside. Armani, you were going to say one. That one, yeah. So that one would end up being arc secant. Yeah.
So for 16.
16.
I did it without inverse. Like on a test.
So like there are technically 2 ways you could do that one. I would recommend, just for the sake of the homework, this is kind of a tricky one. If you're stuck on it, I honestly would not have one like this on your test, to be perfectly honest. But if you are stuck on it, think of writing it like that. But I'll never tell you like how to do something on the test. I just want you to find
So
the
if
antiderivative.
it's right.
If it's right, that's fine, yeah. But if you are stuck on 16, I do often get questions on that one. That one, you're going to force an arctangent by writing the x as the square root of x squared. And then your u would just be root x. And I won't do more of that one, but if you're stuck on 16, that's how you kind of start it out. Any other questions you want to look at today?
For the form bottom, are we just supposed to like explain if we know how to do it?
Yeah, so in the bottom one, I'm not really asking you to find the integral. Like, I just want you to get used to, like, if you look at that, be like, could you find the integral using a rule you know, or is it one that we would not know how to do? Some of them are like, we just don't know how to do them, like, there's just not a way to do them by hand, period. And there's some that we would just not know how to do in this class specifically. So I'm gonna do the same thing for tomorrow. Like, I'll go ahead and kind of, like, if you still have questions, like, please, like, ask them. But use the rest of the period, so it's 3 o'clock now. Use the next 30 minutes to kind of get more homework done. Again, first priority is finishing homework 3. Once you finish homework 3, move into homework 4. I do want it to be kind of self-paced. Like, I don't want you to rush. I really want you to get these down and feel confident with them. But at the same time, don't wait until like next Tuesday to get all this done, because then the test is not going to end up too well. And then it's just like downhill after that. So make sure you're staying on top of it. I'm hoping by giving all these extra days, you don't feel rushed. But that you are using your time kind of wisely to get everything done. So again, if you're at home, like definitely still keep asking your questions. I won't end this meeting